Hello everyone. In this video, I'm going to present a recent work done at the Machine Vision and Intelligent Systems Lab on phenology-aware in-season crop yield estimation through UAV multispectral imagery and deep neural networks. Let us start by discussing why in-season yield estimation is so important. Knowing your crop harvest size months before you actually harvest and being right most of the time is critical for both farmers and crop breeding programs. This is not done with guesswork or slow manual inspections, but using UAVs, multispectral sensors, and artificially intelligent models. Let me take you through this work, which proposes a new way to estimate crop yield mid-season using remote sensing imagery and deep neural models. Farmers and researchers all need early and accurate yield predictions. It helps in planning irrigation, fertilization, pest control, and even a lot of market decisions are dependent on that. But traditional methods rely on late season measurements or slow field scouting, which are not scalable either. That is where phenology comes in, which is the science of plant growth stages. If we can somehow track wheat's growth accurately, we can forecast its yield much earlier. And the hypothesis is that whenever a crop undergoes any biotic or abiotic stress, its phenological patterns get disturbed. So, by tracking these phenological patterns, we can estimate what effect they are going to have over the final crop yield. This approach combines two things. Firstly, phenology, which deals with tracking the exact growth stage of each plot over time, and secondly, morphology, which deals with measuring how many wheat heads there are, their size, their coverage, and their density. We collect high resolution images with UAVs carrying multispectral cameras. These capture details in visible light, near infrared, and the red edge band, giving us reliable indication related to crop health and its growth patterns. We designed a deep neural network called Spark, short for Spatial Phenology Attention and Feature Cross Network, to map each plot's phenological stage. The model itself is built in a way that it's like giving AI not just a photo, but also a sense of time and space as well as existing growth progression. We also fine tuned a unit model for wheathead segmentation. This lets us measure wheathead coverage and density from aerial images, which is also really important for predicting end of season crop yield. Across the 2023-2024 wheat season, we flew 18 UAV missions over 75 experimental plots at NARC Islamabad. And from each flight, we generate orthomosaics, reflectance maps, canopy height models, and vegetation indices. Then we turn all of this into plot level features that the model could learn from. Our Spark model predicts phenological stages with over 92% accuracy. And for yield estimation, we tested different models and found that combining phenology with wheathead morphology improves accuracy significantly. The gradient boosting regressor achieves an R squared of 0.89, which means the yield predictions were very close to actual yield outcomes. Moreover, this framework surpasses all existing state-of-the-art in-season as well as end-of-season approaches. This means farmers and crop breeders can now use it to get accurate yield forecasts weeks or even months before harvest, allowing them to adjust inputs and have targeted interventions. And because this system relies on multispectral imagery alone, it is scalable and non-destructive as well. This method can be adapted to other crops and regions with minimal fine-tuning or transfer learning. Thank you so much for listening, and please let us know about your thoughts in comments below.